so now that we know what rational exponents are, we're going to solve some equations with rational exponents. There's a couple of ways to think about this problem. So we know from what we just learned that the fourth root of a, so this says the fourth root of a, is the same as a to the 1/4 power. So we have a to the 1/4 power equals 14. And we've solved these before, so if we want to get a to the first power, what we know about properties of exponents is that if we raise this to the fourth power, and again, we have to raise the other side to the fourth power as well, we now have a to the first power, because 1/4 times 4 is 1. So a to the first power, just a, equals 14 to the fourth power. So you're going to go ahead and do that 14 to the fourth power on your calculator, and you're going to get 38,416. Now there's one other way to think about this. Now we know that this is the fourth root of a. Well, think about how we undo the square root. We undo the square root by squaring, right? So can we undo the fourth root by taking the fourth power? If we undo the square root by taking the second power, we can undo the fourth root by taking the 1/4, by taking the fourth power, right? So we have 14 again, so taking the fourth power. So we have a fourth root of a equals 14. Well, undoing the fourth root would be the same as raising to the fourth power. So again, if we raise the other side to the fourth power, we're going to get that same answer that we just got above. So there's a couple different ways to think about this problem. All right, let's take a look at another one. Now here we have the 9th root of b to the 5th power. Again, based on what we know about rational exponents, this is the same as b to the 5/9 power, right? So we have the 9th root of b to the 5th power, all right? And that equals 26. So now again, if we want b to the first power, what do we need to raise this to in order to get the first power? Well, we know a power raised to a power, we're going to multiply. So if we multiply this by the reciprocal, we multiply this by 9/5, or we raise that to the 9/5 power, and then we use our properties of exponents, and 5/9 times 9/5 is 1, because those are reciprocals. So now I have b raised to the first power. I'm not going to put the first power in there because it's just b, equals 26. Now if I raise the left-hand side to the 9/5 power, I also have to raise 26 to the 9/5 power. And again, on my calculator, if I raise 26 to the 9/5 power, I'm going to get about 352 and 33/100 if I round to the nearest hundredth. The other way I could think about this is I could say, okay, 26 to the 9/5 power would be the same thing as saying the 5th root of 26 to the 9th power. So I could, in my calculator, take the 5th root of 26 to the 9th power, and I could enter that into my calculator. I would get the same thing, 352 and 33/100. That just depends on how much work you want to do entering that problem into your calculator. Our last one, this one's written a little bit differently because you see we have these parentheses. But those parentheses really don't change the way we're going to do this problem. Remember from your last video, that means the same thing as what we did a moment ago. Parentheses or not, you're going to get the same thing. So we know that the cubed root of c, and then all raised to the 8th power, is the same thing as c raised to the 8/3 power. All right, that equals 47. So we're just going to do this the first way that we did in the last one. So we know that if we want c to the first power, we're going to raise this to the reciprocal 3/8 because 8/3 times 3/8 is 1. So we have c to the first power. Again, I don't need that first power. I'm just going to say c. But if I raise that to the 3/8 power, I also need to raise this to the 3/8 power. So one last time, I enter that into my calculator and say 47 raised to the 3/8 power. I'm going to get approximately 4, and I'm going to round to the nearest hundredth for all of these, 4 and 24 hundredths. Now again, we could do, you know, our 47 to the 3/8 power is the same thing as saying the 8th root of 47 cubed. I could enter that into my calculator as well. Either way, I'm going to get this same result.